This question belongs to engineering mathematics and the topic name is linear algebra. It was asked in GATE 1987 CSE paper. So the question states a square matrix is singular whenever the rows are linearly independent, the columns are linearly independent, the rows are linearly dependent, none of the above. So what's a square matrix? A square matrix is any matrix in which number of rows and number of columns are equal. If we have 3 rows, then we have 3 columns, or we can say basically an n cross n matrix is called a square matrix. What is a singular matrix? A matrix is singular if its determinant is 0. Now let's see what this term linearly dependent and linearly independent means. Let us take an example of a matrix with 3 rows and 3 columns, a 3 cross 3 matrix. It's a square matrix. Let us take its values to be 2, 5, 6, and over here to be 4, 1, 5, and this one to be -2, 4, and 5. So linearly dependent means if we can write any of the row or any of the column as a linear combination of the other rows or columns. Like here, this one is row 1, row 2, and row 3. We can see that row 1 equals to row 2 minus row 3. 2 minus 4 minus 2. 5 minus 4 1. 6 minus 5 1. So here, if we will apply the elementary operations, then we can apply this operation like R1 equals to R1 minus R2 minus R3. Then R1 can be made as 0. And if we can make all the rows or all the columns 0, then determinant will be 0. Thus, if we have a matrix and we have linear dependency, then its row or column will be 0, can be made 0, and thus its determinant will be 0. And if we have determinant 0, then it's called a singular matrix. Thus, a singular matrix will have a linear dependency. All rows are linearly independent? No. The columns are linearly independent? No. We must have a linear dependency. The rows are linearly dependent? Yes. So the option is C. It's the correct.